What can historical albedo tell us about past climates? Imagine looking back in time and being able to read Earth's climate history just by examining how much sunlight its surface reflected. That's what historical albedo helps us do. Albedo is the measure of how much sunlight Earth's surface bounces back into space. In polar regions, where ice and snow are common, the surface has a very high albedo because these surfaces reflected most of the sunlight that hits them. When scientists study past albedo values, they can get clues about how much ice and snow covered the poles at different times. If the albedo was high in the past, it suggests there was a lot of ice and snow, which kept the climate cooler. If the albedo was lower, it means less ice and snow, pointing to warmer periods. This pattern helps us understand how Earth's climate has changed over thousands or even millions of years. The relationship between ice and albedo is very important. When ice melts, it exposes darker land or ocean surfaces that absorb more sunlight. This causes the surface to warm up more, leading to even more ice melting. This process is called the ice albedo feedback. It makes the climate more sensitive to changes and can speed up warming or cooling trends. By analyzing ice core samples, sediment layers, and even ancient snow deposits, scientists can estimate how Earth's albedo changed over time. These records show us how ice sheets expanded during ice ages and retreated during warmer interglacial periods. During the last ice age, for example, the high albedo from massive ice sheets kept the climate cold. When the ice melted, the albedo decreased, and the Earth warmed up. In recent history, satellite data has helped us see how Arctic albedo has decreased over the past few decades. This decline is linked to the rapid melting of sea ice caused by global warming. These changes in albedo are not just local, they influence the entire planet's climate. Polar regions act like amplifiers. Small shifts in ice cover can lead to bigger changes in global temperatures. That's why studying past albedo gives us a clearer picture of how sensitive Earth's climate system is. It also helps us improve climate models, which predict future changes. Knowing how surface reflectivity has changed over time helps scientists understand how Earth's climate responded to natural and human influences. So, by examining historical albedo, we learn about past ice cover, surface conditions, and temperature shifts. It shows us how feedback loops worked in the past and how they might operate in the future. This knowledge is key to understanding Earth's climate history and preparing for what lies ahead, especially in the polar regions where changes happen fastest.